Hello, and this time I'm talking about set builder notation, and we can define sets with, just a rule or a list or something like this. But we also have these sort of funny letters where we can define a big group of numbers and say that x is one of these. And so it might be the first one is n, which has this sort of like double line on it. I'm not very good at drawing freehand on the screen. And these are the natural numbers. Okay, so the positive whole numbers. That's what natural numbers are. So we don't allow 0 in this because 0 is neither positive or negative, and the natural numbers are the positive numbers. Okay, a lot of people call them the counting numbers because 1, 2, 3. They're the numbers that you count with. When you're counting sheep, you can't have decimals. You either have a sheep or you don't. And then we have the integers, which are positive and negative whole numbers, and 0 as well. You can have that in there. Then we have the irrational numbers. No, sorry, the rational numbers. Sorry, Q is the rational numbers. So anything that can be defined in a ratio. So, 5/2, a third. So even though it's a recurring, it still can be represented as a fraction. And that also includes, of course, all the integers and, of course, all the natural numbers. They sort of build on top of each other. And then after the rational numbers, then we get the real numbers, which includes the I've made that slightly too wide, which includes the irrational numbers. So we can now have pi and e and √2 and all these other numbers. These are all real numbers, even though they don't have a finite decimal representation. So those are our 4 that we can work with. And then we'll just do some examples, see what we get. So the first thing, we can have x between -3 and 4. Okay, but we can't be these numbers because they're strict inequalities, and we have to be integers. We have to be a member of. That's what that E shape means, is a member of. And x is a member of the integers. So we are allowed negatives. So -2, -1, 0, 1, 2, and 3. Those are the values we can have. Can't be -3 or 4, strict inequalities. Here it's saying that x is less than 5, and we are a member of the natural numbers. So the smallest thing I can be is 1, 2, 3, and then 4, and then that's it. I can't be 5 because of the strict inequality. And this time, in between -6 and -1, but I want the natural numbers, and there are no natural numbers in between -6 and 1 because the natural numbers have to be positive, and these are all negative. So we just say that this is the empty set. There's no one in it. There's nothing that complies with both. Express in set builder notation the set of natural numbers which are even. Well, it seems a bit straightforward, but you can just say the even numbers and then say that x is a member of, and we want the natural numbers like that. Okay, which is going to stop us having any negative even numbers, -2 or -4, etc., etc., because we've been asked for just the whole numbers, the positive numbers, just the natural numbers, so we write that down. Factors of 24, well, there's no... Oh, sorry, I've got to say that actually this one, you can write it down slightly more formally. You can write the even numbers as 2 lots of x, can't you? Because if you have any number, well, any natural number, certainly, and any integer, and then you times it by 2, then you will definitely get an even number, and you can define all of the even numbers in that way. But factors of 24, I don't think there's a way I can write that out as a rule, like 2x, so I'm just going to write x is the factors of 24, and also that x is a member of the natural numbers. That's what it asked me for. And then finally, between -1 and -4, I could just write it formally as -1 is less than x inclusive, so put the equals on, less than or equal to 4, and then we can say natural numbers. So we can say x is a member of the natural numbers again. Just be careful though, because here, there's nothing wrong with this. The natural numbers sort of is excluding the negative, but in a way you don't really need to say it, do you? Because you can't have -1, because it's not a natural number. You can't have 0, and then we can have anything up to an equal to 4. So we could technically get rid of that bit and just say that x is less than or equal to 4. That's sufficient because the phrase the natural numbers is sort of clearing out all the negatives and the 0. Solve the inequality where x is an integer, give your answer in set builder notation. This is more likely what you'll need to do, although more likely in the exam, they'll write something like this. They'll say, solve the inequality, blah, where x, and then it will say, something about real numbers or something like that, just to be concise and clear with the question so no one can argue. But you don't really need to know what it does. So let's just have a look at this one. Solve the inequality. So we've got 3x minus 3 less than or equal to, try that again, 4x plus 1. So move that over, and we get x is less than or equal to minus 4. Take 3 off both sides, take 1 off both sides. Yep. So we've got that x is greater or equal to minus 4. But it tells us that where x is an integer. So this is the set builder bit. We're then going to say that x is a member of the integer numbers, like that. And that's all it is, really. It's just a familiarity with what these things mean, which you've probably seen on questions millions of times before, where they strive to be precise so no one can argue. And it's just a case of recognizing that z means you're allowed to be positive or negative, but whole numbers. N is only the positives. Q, that we had up before, any rational numbers, and R is the whole set of real numbers. Okay, if you have any questions on that, pop them down into the comments. But otherwise, cheerio.